This video is going to do 3 problems on weighted averages. A weighted average is different from a regular average in that normally in an average we would take all of the numbers that we were dealing with, add them up, and divide by how many there were. Now we're taking an average in which the numbers that we're putting into the average are either worth more or less than the other numbers we're putting in. So for example, in this problem it says Ted wants to figure out his grade in English. The chart below shows his 5 essay grades and the percent of his grade that each essay is worth. What is Ted's percent for the class? As you can see, essays 1 and 2, perhaps the essays they started with at the beginning of the year, are only worth 10% each, whereas the next two are worth 20% each. Okay? They're worth a little bit more, and the last one is worth 40%. So that 5th essay is worth more than the first one. Now this is going to affect how we do the average. As I said, normally if we just wanted to average all of his essay grades together, we would add the 5 of them up and divide by 5. Well, we can't quite do that here because that would mean that every essay is worth the same amount. So instead, we're going to say that 10% of the average, or 1/10, comes from 92. So we're going to take a tenth of 92, 10% from 86, 20%, or 2/10, from 78, 20% from 80, and 40% from 90. I like to think about it that each score is contributing in some way to the final score, and they're contributing some percentage of themselves. So 1/10, right, this is 1/10. 1/10 of 92 is 9.2. 1/10 of 86 is 8.6. Now 2/10 of 78 is 2 times 7.8. I really thought of this as 2 times 1/10 times 78. 1/10 of 78 is this 7.8 I've put here. 2/10 of 80 is 2 times 8.0, and 4/10 of 90 is 4 times 9.0. So 9.2 plus 8.6 is 17.8. 2 times 7.8, well, 2 times 7 is 14, and 2 times 0.8 is 1.6. So 2 times 7.8 is going to be 15.6. 2 times 8 is 16, and 4 times 9 is 36. 17.8 plus 15.6, well, 17 plus 15 is going to be 32. So 32, and then 0.8 and 0.6 is going to be 1.4, so we're going to get 33.4. 16 plus 36 is 40 plus 12, so 52. And then 52 plus 33.4 is 85.4. And that is his percent for the class, and I imagine it would be rounded down to 85% to get a whole number. So Ted's average in the class is an 85% based on the 5 essays and how much they were weighted. Our next example says, Mary wants to figure out her grade in math. The chart below shows her 3 test grades and the percent that each test is worth. If the final exam makes up 50% of her final grade, is it possible for Mary to get a 95 in the class? If so, what will she have to score on the final exam? So here we have a different unknown that we're solving for. Instead of trying to figure out what her grade will be, we want to know what she wants to get on the final exam in order to have her grade come out a certain way. So the first test was worth 15%, so 15 hundredths times 90. The second test was also worth 15%, so 15 hundredths times 85. The third test was then worth 20%, so 2/10 times 100. And the last test is worth 50%, 5/10, and we don't know the value of the score that she's going to get on the final exam. That's our unknown here, and we're hoping that we can solve for x and make this all come out to a final grade of 95. So 0.15 times 90, you can do the percentages out, and a quick way to do 15% of something is take 10% of it and then also 5% of it. So 10% of 90 is 9. Half of 9 is 4.5. So you know that 5% of 90, right, is half of 10%, so it's 4.5. So 9 plus 4.5 is 13.5. I won't make you do the same thing out for 15 hundredths of 85. If you multiply it on a calculator, it comes out to 12.75. Plus 2/10 of 100, well that's 20% of 100, which is 20, and then we have this 0.5 times x, where we don't know her final exam score, but we're hoping we can get it to come out to 95. So 13.5 plus 12.75, I'm going to write that one out, 13.5, bring that 5 down, 12, 6, 2, so 26.25 plus 20 is going to get us 46.25. Okay, so I added in that 20 there. Then we still got our plus 1/2 of x is equal to 95. So I'm going to subtract 46.25 from both sides. So 5/10 of x, or half of x, has to be 49.75. So I'm going to multiply by 2 on both sides, right, because 0.5 is 5/10, which is 1/2. So that cancels out. X has to equal 49.75 times 2, which comes out to 99.5. So what does that number mean? Okay, that was our x, was our unknown here that we were looking for. That means that Mary must get a 99.5 on the final exam in order to have an average score of 95 for the whole year. Alright, no chart in this one. Let's see if we can make sense of what they've got here. It says, to earn a B in geometry, Abby must get an average of at least 80%. Okay, so far maybe we know that there's a goal that she wants to get a B in this class. Abby's test scores, okay, I'm going to write these down. So her test scores are as follows. So test 1 was an 85. Another test, so test 2, she got a 90, and on the third test, she got a 75. Then it says her quiz average is a 75, and her homework average is a 90. Next sentence says both her quiz and homework averages are worth a test grade. What that means is that these 5 scores, the 85, the 90, the 75, and the other 90, they are all worth the same amount. Okay, so whatever percentage they are of the final grade, it will be the same percentage for all 5 of those numbers, of those scores. Then it says her final exam score counts as 3 test scores in the average. So her final exam score is worth 3 times as much as one of these numbers over here on the left that I underlined in green. So it says Abby got a grade of 78 on the final exam, and that one is not worth the same as those first 5 scores, okay, the test scores or the quiz and homework averages. It's worth 3 times as much as that. So let's suppose each of these things, test 1 is worth 1 thing, okay, test 2 is worth a test, test 3 is worth a test, right? Those are each tests, so they're worth the same amount as a test. The quiz average is worth the same amount as a test, and the homework average is worth the same amount as a test. So each of those things is worth 1 test grade. The final exam is worth 3 test grades. So that means we have 5 things that are worth a test each, and 1 thing that's worth 3 tests. Well, 1 plus 1 plus 1 plus 1 plus 1 plus 3, right, that's 5 plus 3. There are a total of sort of 8 pieces here that influence the final grade. Okay? 5 of them are individual scores that come from the tests, the quizzes, and the homework, and then 3 of those pieces come all from the final exam. So I can consider the first test to be 1/8 of her final score, the second test to be 1/8 of her final score, the third test to be 1/8, the quiz average to be 1/8, the homework average to be 1/8, and then the final exam is going to be worth 3/8. Okay, so if I add up all those pieces, I get a total of 8/8, or 1, which is 100% of the grade. So let's see what happens when we put these together. So we need 1/8 of 85, 1/8 of 90, plus an 1/8 from 75, plus an 1/8, another 1/8 from 75, plus an 1/8 from 90, and then we need 3/8 from that final exam score of 78. Because of the distributive property, I can take all of these 1/8 from the first 5 terms and factor them out and say, so 1/8 times 85 plus 90 plus 75 plus 75 plus 90. Okay, so I plug that part into a calculator, and that part will get us 51 and 875 thousandths. Okay, so 51.875. Then we want to know what 3/8 of 78 is, and that comes out to be 29.25. So if we add those together, her final score is an 81.125, which is probably going to be rounded down to an 81%, but our question was, did she get a B? To get a B, she has to have at least an 80%, so yes, Abby earned a B.